Today we'll be learning about linear functions and slope-intercept form. This is section 2-3 in the textbook. The benchmarks that go along with this are listed here. Your objective is that you will be able to graph linear equations and write equations of lines. Two formulas that you need to remember from Algebra 1. Slope is the vertical change over the horizontal change, or rise over run. We use the formula y2 minus y1 over x2 minus x1. Slope-intercept form is a way of writing a linear equation, and it comes in the form y equals mx plus b. It's known as slope-intercept because m tells us the slope and b tells us the y-intercept. So we have a slope and an intercept, making it slope-intercept form. Let's look at finding slope. What is the slope of a line? We're going to first look at slope on a graph. Since this graph has no points on it, we need to make some points. You want to find points that are exactly on the crosshairs of the grids, like this one here at the y-axis. We could also use this one up here, or go up a little further, and this one. But as long as you pick two. And then we're going to count the rise, which is 1, 2, 3, over the run, which is 1, 2. That makes the slope of this graph m equals 3 over 2. We went up, which is positive, and to the right, which is also positive, so therefore the slope is positive. Make sure that when you're counting rise over run that you watch out for going down or left, which are negatives. What is the equation of this line? We're going to use the formula on the previous page, which is y equals mx plus b. To use this formula, we need two things, m and b. M is the slope, which we found above. B is the y-intercept, which is where the graph crosses the y-axis. So in this case, b equals 1, as the green line crosses the y-axis at 1. Now that we know m and b, we can write our equation as y equals 3 over 2x plus 1. The only letters we plug in for is m and b. The y and the x stay y and x. Now let's look at how to find slope between 2 points. So when we're looking for the slope of a line that passes through the given points, we're going to use the formula m equals y2 minus y1 over x2 minus x1. So if we look at the first example, we can call this x1 and y1 since it's the first point, and this one x2 and y2 since it's the second. You can reverse these. Just make sure that x1 and y1 are in the same point, and x2 and y2 are in the same point. So now using the formula, we find that m equals, we start with y2, which is 4, minus y1, which is 7. There is always a minus sign in the middle. Next we go to x2, which is negative 2, minus x1, which is negative 3. I put it in parentheses because there's a double negative. A double negative is going to turn into plus a positive. So when I do the math, I find that 4 minus 7 is negative 3. And on the bottom, negative 2 plus 3 is 1. So then we reduce that and find that the slope equals negative 3. Now let's go to the next example. Once again, let's call this x1 and y1 and x2, y2. If you would like, you can try reversing them on your paper to see if you end up with the same answer as me. You should in the end. So let's begin. M equals, start with y2, which is 1, minus y1, which is also 1. Then x2, which is negative 4, minus x1, which is 3. On the top, we get 0, and on the bottom, we get negative 7. 0 divided by negative 7 is 0. So this time, m equals 0. This is not undefined or no slope. Because 0 is a real number, this is called a zero slope. Let's look at the final example. Once again, we'll call this x1, y1, x2, y2. Plugging into our formula, we find that m equals 1 minus negative 3 and 7 minus 7. Once again, minus a negative becomes plus a positive, and on the top we get 4 over 7 minus 7, which is 0. 0 cannot go into 4. 4 cannot be divided by 0. It gives you an undefined answer. So this time the slope is undefined. We call this one no slope. So let's look at a wrap-up of slope. A positive slope starts in the bottom left-hand corner and rises up to the right. An example would be m equals 5 over 7. A negative slope starts up in the left-hand corner and falls down to the right-hand side. An example of a negative slope would be m equals negative 3 over 5. A zero slope is a horizontal line. It goes through the y-axis. An example of that is m equals 0 over 9 equals 0. Easy way to remember it is if we trace the horizontal line, we can make a z out of it for zero slope. An undefined slope is a vertical line. An example of undefined slope is m equals 8 over 0, which equals no slope. An easy way to remember that is if we trace the vertical line, we can make the letter N for no slope. Now let's look at writing equations in slope-intercept form. Sometimes the equations will come in this part looks like standard form, and sometimes it will come in other forms. We need to be able to know how to manipulate these to make them into slope-intercept form. Remember that slope-intercept form is y equals mx plus b. We need to get y all by itself. So we're going to start with moving the x term. If we have 5x, we can subtract 5x to both sides. 5x minus 5x gets rid of this term to leave us with negative 4y equals negative 5x plus 16. We want the x term first and the number second so that it begins to look like mx plus b. Last, we need to get rid of the negative 4 timesing the y. The opposite of timesing is to divide. So let's divide by negative 4. When we do that, we must divide everything by negative 4. So we divide the 5x by negative 4, and we divide the 16 by negative 4. The two negatives over here become positive. The 4's cancel out, leaving us with y equals. Now the y is all by itself. So let's simplify the right-hand side. Once again, these two negatives become a positive, and 5/4 cannot be simplified, so we leave it as 5/4 x. Then we look at 16 over -4. 16 over -4 simplifies to -4. Remember that plus and negative, positive and negative makes a negative, and 16 over 4 makes 4. Now we are in slope-intercept form. From here, we would be able to graph. Sometimes your equations will have fractions in them, and we will need to get rid of these fractions. To do this, we find the common denominator. A common denominator between 4 and 2 would be 4. So what we're going to do is we're going to multiply the entire equation by 4. Everything gets multiplied. When we multiply to a fraction, we think of it as 4/1. So it becomes -12/4, which reduces to -3x. The purpose of multiplying by the common denominator is to eliminate the fraction. So then we do 4/1 times 1/2. This gives us 4/2, which reduces to plus 2y. Then last we multiply the 4 times this, and we get -4. Now the fractions are gone, and we can proceed as we did above. Once again, we need to begin by getting rid of the x term first. So we're going to add 3x to both sides. So we end up with 2y equals 3x minus 4. Once again, putting the x term first and the number second. Since we added 3x, it stayed a positive, and this was a -4, so it became a -4. Remember that when you add x to a number, since they are not like terms, you cannot combine them, which is why it becomes 3x minus 4. Last, we need to divide everything by 2. This cancels out the 2 in front of the y and gives us the final equation of y equals 3/2x minus 2. And once again, we're in form, ready to graph. So let's look at graphing. Here we have two equations that we're going to graph. The first one is already in mx plus b form. All we need to do is make our m an actual slope of rise over 1. So we put it over 1 to make it a fraction. So 2/1. 2 is our rise, 1 is our run. When graphing a line, we always start with the y-intercept. In this case, it's +1. So we go over to our graph on the y-axis and go up 1 and make our first dot to represent our y-intercept. From there, we're now going to use our slope of rise 2, run 1. So from that dot, we're going to rise 2 and run 1 and make another point. And we can continue that pattern, rising 2, running 1, until we run out of graph. Now our dots are only going in one direction, but a line goes on forever in both directions. So to make dots in the other direction, we can do the opposite of rising 2 and running to the right 1, which would be going down 2 and running to the left 1. Down 2, left 1. And once again, you can continue that pattern until the end of the graph. Down 2, left 1. Now that we have dots all the way across the graph, you can make a line by using a ruler and drawing through all of those points. Make sure to put an arrow on both ends because even though the dots stop, the line still continues on in both directions. Now let's look at the next one. This one is not in slope-intercept form, so we need to begin by putting it in that form. As we did on the previous page, we're going to start by moving the x term. So we're going to say minus 4x to both sides. Then we get negative 7y equals. Remember, we cannot combine these, so we're going to put the x term first, which is negative 4x, and the number second, which is a positive 14. Then to finish getting y by itself, divide by negative 7. Make sure that you divide everything by negative 7. So the negatives and 7s cancel, and now we have y equals negative over negative makes a positive 4 over 7x. And then positive over negative makes a negative 14 divided by 7, which is 2. Now we know what our slope is and our y-intercept, and we're ready to graph. So let's graph this one. Once again, we're going to start with our y-intercept, which is negative 2. So we go to the y-axis, and this time we're going to go down 2 spaces and make your first point. Then from there, we're going to use our slope of rise 4, run 7. So we're going to go up 1, 2, 3, 4, and to the right, 1, 2, 3, 4, 5, 6, 7. Since we're at the end of the graph, we don't need to make any more dots, but we do need to go in the other direction. So instead of rising 4 and running 7, we're now going to go down 1, 2, 3, 4, and instead of to the right, we're going to go left 1, 2, 3, 4, 5, 6, 7. We only have 3 points this time, but 3 points is enough to make a line in both directions. So once again, we take a ruler and draw a line through our dots. Making sure to put arrows on both ends to show that the line continues on forever. That is the end of your lesson. Please open up assignment 2-3 and work on the problems. Remember that you can go back to this video if you get stuck. Bring in any questions that you have to class tomorrow.